Alright, today's lesson is on electrical system of a R22. Starts off with a simple electrical system. It's got a 14 volt bus bar, and it's got 5 key components to it. You've got your battery, an alternator, a voltage controller, the battery relay, and the circuit breakers. This battery that runs the R22 is a 12 volt 25 amp hour battery. You have the alternator of a 14 volt 60 amp alternator, where we've got the voltage controller, which is switched on and off by the alternator switch, and the battery relay controlled by the master battery switch. The voltage controller protects the electrical system from over voltage and protects it from burning up on you, kind of like the circuit breakers do. And then you got the master battery that turns on and off the battery relay, which disconnects the battery from the rest of the electrical system. So going from there, we've got different key parts of it where the tachometer and the lights still work when the battery is turned off, and the alternator. But with that being off, the clutch switch must be turned on still, otherwise you're not going to have any power at all. That comes in useful for when you have any kind of an issue where you have to turn off your master battery and your alternator switch in case of an electrical fire or auto rotation or some other emergencies that end up taking place. That way you still have your RPMs to use it so you can land safely. We've got the circuit breakers that are like a push-pull type of circuit breaker. You've got all of the light system, the position lights, the strobe light, and the landing lights are all on their own circuit breakers. The control panel is on a circuit breaker where the map is connected in with the navigation, but the rest basically have their own circuits. The strobe light ends up coming in handy, having that one pulled off if you end up having anyone that has vertigo or has that kind of just sickness from being in the air or whatever. That light can trigger it, so you can pop that out and be able to fly. The navigation lights are on the side of the fuselage, where the strobe light is on the tail boom up top, and then you have the landing lights up in the front of the helicopter on the nose of it, positioned at 2 different angles, which provides you as the pilot to have a more clear view, a more lit up area for when you're coming in for a landing. A couple other things when it comes to the circuits, that you have the cylinder head temp gauge. That is a gauge that becomes very important to look at aside from the rest of them, but all equally as important. The cylinder head temp, if that goes out, it also lets you know that if you pull up your POH and take a look, on the R22, the main rotor chip, the tail rotor chip, the low fuel light, the low oil pressure light, the low voltage, the carbon monoxide, and the governor light switch, it lets you know that those are not working. If the cylinder head temp gauge isn't working, those are not working, which means your governor, you're not going to know if it's working or if it's not working unless you go and manually look at it and check to see if it's still on or off, which can poses a threat if that light's not working. You happen to turn the governor switch off, you're going to end up having an issue where you can raise up on the collective, and next you know you're going to overspeed your RPMs and you're going to have some issues going on. Or you can go and lower the collective and get yourself into a whole world of trouble if you don't catch it quick enough, where the governor is not going to be there to control the RPMs, and you can get yourself into a low RPM warning situation, if not into a blade stall, which is not good, which we'll end up getting into here in a couple lessons. But as for the electrical system, it's a pretty simple system, and it works really smooth. So yes, thank you.